secondly, we are also going to consider rotational equilibrium. Now, when we are considering the rotational equilibrium, we are going to take moment about one of those points. But for this particular question, since they want the coefficient of friction, I'm going to take moment about point A and not point B, because at point B there is a frictional force acting on it, and our interest is to find the coefficient of friction. So this implies that if we take moment about B, we shall not find our coefficient of friction because it will be 0, since its perpendicular distance from the turning point will be 0. So it is better we take moments about point A. So we say, I can write taking moment about point A. So if I'm to take moments about point A, I'll be considering each force at a time. So at point A, the first force I have is R2. So I'll have R2 times the perpendicular distance from the turning point. Its perpendicular distance is 0. Plus, then the next force is 20G. Now this 20G, consider as if it is the only force acting on the ladder, and you see which direction it will take the ladder. You realize that the 20G will take the ladder in the clockwise sense. And when we are taking moments, clockwise direction is taken as negative, and then anti-clockwise is taken as positive. So that implies that I will have negative 20G times the perpendicular distance. Now this time round, we still don't know the perpendicular distance, and we are supposed to find it. Don't say that the perpendicular distance is 2.5 meters. No, it is not. So what you're going to do, you're going to extend the line of action of the weight, which is 20G, and then you see where to meet a line which is coming from the turning point, where they are going to make an angle of 90. I'm going to call this C, this is going to be D. So the perpendicular distance of the 20G from the turning point is this, which is AD. So I'll have it as AD. Plus, the next force is F, the frictional force. Also the frictional force, if you consider as the only force acting on the ladder, you'll see that you will take the ladder still in the clockwise direction. So it means it will also be negative. So I'll have negative F times its perpendicular distance from the turning point. This is the line of action of the frictional force, and then the turning point is here. So it implies that the perpendicular distance is going to be AC. Then plus, the last force that is acting there is R1. So when you look at R1, if it is the only force acting on the ladder, it will take the ladder in anti-clockwise sense. That means R1 is going to be positive. So we shall have R1 times the perpendicular distance from the turning point. Its perpendicular distance, we first reproduce its line of action, and if we reproduce that, it will meet the line that is coming from the turning point at point, let's call it E. So it means its perpendicular distance is going to be AE. And when you have all those forces, it should give you 0. So we are going to find these lengths AD, we want to find AC, we want to know also AE. Now, from triangle ABC, you will see that we have something that looks like this. Let's go back to our diagram. Let me put this as my angle theta. So it means this is my A, this is where C is, this is where my B is. So this is the theta, and the distance here is 3 meters, and this one is 5 meters. So if I'm to find AC, I use Pythagoras theorem. So this is equal to a root of this 5 squared to be 25 minus a square of 3, which is 9. So AC alone is going to give me 4 meters. So the next is, I also need to find, if I want a cosine of theta from this same triangle, it is the same as adjacent over the hypotenuse, which is 3 out of 5. So, and when you look at this, when you come back to our original diagram, if this is theta, this triangle is similar to this other triangle. So this implies that by alternate angle properties, this is also going to be angle theta. So it means if I want if I want AD, it is the same as I'm going to consider this small triangle. This angle is adjacent to AD. So it implies AD is going to be 2.5 cosine of theta. I love this is 2.5 cos of theta. And of course, the last length, which is AE, you are also considering the big triangle now. This one, like that. So AE is adjacent to angle theta. So that implies that AE is going to be 5, the whole length, which is 5, cosine of the angle theta. 5 cosine of theta. So I'll have to come back here, and then we see. We replace all what we have got. So it implies that this is going to be 0, and I will have negative 20g times AD. AD is 2.5, which is 2.5 is the same as 5 out of 2, times a cosine of theta, which is 3 out of 5. And then plus, I have negative f, and our f is actually 20 g mu. So I'll have negative 20 g mu. And then 20 g mu times AC, and our AC is 4. And then plus, and the next is R1. Our R1 is the same as 20G. So I'll have 20G times AE. AE is 5 cosine theta. Cos of theta is 3 out of 5. And this is going to be equal to 0. So for this case, 5 and 5 are going to reduce and gives 1. And then I will have, this is going to reduce to negative 10, and this will be times 3. I'll have negative 30G. And then plus, this is going to give me negative 80G mu. And I'm going to add, this is going to reduce, and this is going to give positive 60G, which is equal to 0. So I have I have these common terms. When I add them, I'll have this is going to be positive 30 which is equal to, I take this the other side, I will have 8 G mu. So G and G are going to cancel, and therefore my mu alone is going to be 30 out of 8. And then mu is going to be 3 out of 8. Or if you press from your calculator, this still gives me 0.375. So that is what you are required to find. Thank you very much. Subscribe.